In this video, we will learn to solve each of these equations for the angle between 0 and 2 pi. There will be two answers when we have the entire circle to work with because of the way reference angles work. All right, reference angles always sort of go like this. Okay, so these are the four places where reference angles occur. And so reference angles, when you take a trig function of an angle, it's always the same as the reference angle, except for two of these will be positive and two of them will be negative. So if I want to find the angle that will give me positive 2 radical 3 over 3, there'll be two of them. All right, it'll be the two that are positive. Let's convert this problem over to a form with which we are more familiar. We know that secant is the reciprocal of the cosine function. So if this is the secant, that means that the cosine must be 3 over 2 radical 3, since these are reciprocals of each other. Okay, so you should be asking yourself, cosine of what angle is going to give me an answer of 3 over 2 radical 3? Now this kind of looks familiar, but if you look at the 6 values that we always write down right at the beginning, none of these values quite match. All right, these look sort of similar. Okay, but not exactly. They have the radical 3 and a 2, but so here's what's going on. You can make this look a little bit different by rationalizing the denominator. If I were to multiply by the radical in the top and the bottom, that will make these go away. So that's going to give me, so let's see, cosine of theta equals, so I've got 3 radical 3 right now, and I've got my 2. Now radical 3 times radical 3 is just 3, like that. But now look, these 3's are going to cancel each other out. So that means I've got the cosine of theta is equal to radical 3 over 2. So the moral of the story is, when you see that 3 and the 2 and radical 3, and you know that the options are either radical 3 over 2 or 1/2 or 1 over radical 2. Well, you're seeing a radical 3 and you're seeing a 2. Okay, in the original problem, there's your radical 3, there's your 2. So you can bet that it's going to be the same thing as radical 3 over 2. Okay, so here we have the cosine of what angle is radical 3 over 2? Well, that's the cosine of pi over 6 is radical 3 over 2. This is one of the 3 that we just plain memorized. So pi over 6 should be the first thing that pops into your brain. Now, pi over 6 is the reference angle. All right, it may or may not be the actual final answer, or one of the final answers. But it lets us know how to draw the picture. So let's go ahead and draw the picture. We're drawing pi over 6's, all right? That was kind of the point, was to find the reference angle. So there's pi so far, all right? The semicircle is pi. If I split it in half, now I have pi over 2. All right, but if I want pi over 6, I need to split each one of these into 3 parts. So that's what I'm going to do. So if I take this and go like this, and if I take this and go like this. Okay, so now I've got 3 parts. Let me do that again. Okay, so now I've got 6 parts up here. All right, so that's pi over 6. Now, the reference angles are right here above and below the x-axis. So these are the 4 reference angles. Okay? Now, if I take the cosine of any one of these, it's going to give me radical 3 over 2. But 2 of them will give me positive radical 3 over 2, and 2 of them will give me negative radical 3 over 2. I want the 2 of them that will give me positive radical 3 over 2. So cosine is the x value. And so where are the x values positive? What quadrants? X values are positive to the right of the y-axis. So these are the 2 that are positive cosines, positive x values. So these are the 2 answers that I want. Of course, this first one is just our original pi over 6. So that actually is one of the answers this time. It won't always be. Okay, so that is one of the answers. The other one is this one. Now, remember there's 6 in the top, 6 in the bottom. So if I went all the way around, that would be 12 pi over 6. So if I back up 1, that's 11 pi over 6. Okay, that was just to save me from counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6. But whatever makes you happy. So these will be the 2 answers for number 11. All right, let's take a look at number 12. All right, the tangent of what angle is 0? Well, there's 2 different ways to do this. There's the way that you can do it by yourself, and then there's a way of just looking at a completed unit circle. For right now, I'm going to pretend that I don't have a completed unit circle to look at. But I know in my brain that the tangent of theta, tangent is sine over cosine. So tangent theta is going to equal sine theta over cosine theta. And that has to be 0. Now, if you have a fraction that's equal to 0, the only way that's going to happen is if the numerator is 0. Okay? This is only, you only get 0 if you have like 0 divided by something. All right? It doesn't have to be a 1, but you know, it's got to be 0 over something. So in other words, the sine function, sine has to be 0. The y value has to be 0. So let's just draw a quick unit circle and see where that is. All right, so here we go. Remember, right here, the coordinates are 1, 0. Up here, they are 0, 1. Over here, they are -1, 0. And down here, they are 0, -1. Okay? Now, the y value has to be 0. All right? I need 0 over something. And tangent is going to be like 1 over 0, 0 over 1, -1 over 0. Okay? So, these are the 2 locations that I need. All right? Because the tangent here, all right, the tangent here would be 0 over 1. All right? So that will give us a tangent of 0. This angle is 0, or 2 pi. This one over here, the tangent would be 0 over -1, which is also 0. So over here, this is tangent of pi. So, so we've got 0, or 2 pi, and we've got pi. These are the 2 angles that would give us a tangent of 0. Now, as I have to choose between calling it 0 or calling it 2 pi, I need to look at the directions. They said they want theta to be between 0 and 2 pi, but it has to be less than 2 pi, not equal to. It can equal 0. So there's my answer. I'm going to go with calling it 0. So 0 and pi. Those are the 2 answers for number 12. All right, let's do two more. Tangent of what angles will give us radical 3 over 3? Let's see, tangent is equal to sine over cosine, right? So I say we look at our chart of values, our 6 values that we always write down, and let's look at the tangent of each one of these and see which one might equal radical 3 over 3. Okay, so let's take a look. So for this one, the tangent of pi over 4, this over this is just going to be 1. So there's no way that 1 is equal to radical 3 over 3. All right, how about pi over 6? Well, sine over cosine, that would be 1/2 over radical 3 over 2. Now remember how the denominators will cancel out. So it's really going to be like 1 over radical 3. Okay, so the tangent of pi over 6 would equal 1 over radical 3. Now, this one has potential. It's got the radical 3 in there at least. So maybe, and here my radical 3 is in the denominator. So we've talked about rationalizing the denominator. In other words, getting the radical out of the denominator. So let's do that and see if somehow it becomes radical 3 over 3, because then that would be our answer. So the way we get the radical out of the denominator is by multiplying the numerator and the denominator by the radical. If I do that, then I'm going to wind up getting, okay, 1 times radical 3 is just radical 3. And then radical 3 times radical 3 is 3. So we find out that, in fact, 1 over radical 3 is the same thing as radical 3 over 3. So I think we have our answer. So tangent of pi over 6 is the same, is equal to radical 3 over 3. So pi over 6 is our reference angle. Now, pi over 6 may or may not be one of the actual answers. Remember, there are 2, so don't just put pi over 6 and run away and go do something else. You have to draw a picture and understand what's happening. So let's draw a bunch of pi over 6s. So here we go. All right, pi over 6s are the trickiest ones to draw because they're so small, but that doesn't scare us because we're awesome. We are so awesome. Okay, see how there's 6 up there? That's how you know they're pi over 6s. Now, reference angles, there are 4 of them. Here, 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 and here. The tangent of any one of them is going to give me radical 3 over 3. But 2 of them will be positive and 2 of them will be negative. Okay, now, sine over cosine, right? In the first quadrant, the sine is positive and the cosine is positive. So that gives me a positive tangent. I'll break it down later. In this quadrant, sine over cosine, sine is positive, cosine is negative. So that's going to give me a negative tangent. All right, right here, sine over cosine, sine is negative and cosine is also negative. A negative divided by a negative is a positive, so that'll be a positive tangent. And over here, cosine, the x values are positive. Wait, I'm doing sine over cosine. So sine, the y value is negative. Cosine, the x value is positive. A negative divided by a positive is a negative. Okay, so I have circled here the value, the sign of tangent in each quadrant. Now, our original problem was positive, so we want the two locations that will give us a positive tangent, here and here. Okay, so these two locations are the answer. Now, what are they? Okay, well, the first one is just simply pi over 6. Okay, because it's like 1 pi over 6. But then it's 2, 3, 4, 5, 6, 7 pi over 6 is the other one. So these are the two answers, pi over 6 and 7 pi over 6. All right, one more example. When I see just a 0 or a -1, I like those because they are extra easy. All right, so just look at your basic unit circle, your pi over 2's, if you will. All right, if you look at that, then look at these 4 coordinates. All right, here we've got 1, 0, 0, 1, -1, 0, and 0, -1. The x values are the cosine. Okay, so cosine, 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 cosine. All right, but we want the one where the cosine is -1. All right, only one of these have a cosine of -1. And it's this one right here. Okay, so what angle is this? Well, that is pi. So pi is the only answer to this question.